Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course. States of matter. Today we begin with lecture 10 from the course, but make sure you watch the previous ones before viewing this one. So in the last lecture, the topic that we discussed was the second gas law, that is the Charles law. And today we will be increasing our understanding of the law further with a few numerical problems based on the Charles law. So this is something that will really help you in your problem solving when it comes to the questions related to the Charles law. So the first question that I have chosen for you is essentially the recap of the law. I wanted to just revise the law with you before we can see the other questions. So I have chosen this question. And the question says that the Charles law states that the volume V of a confined gas is directly proportional to the temperature T in Kelvin according to the relation V1 by T1 equal to V2 by T2. So I hope you remember this. We have discussed in detail how the volume of a gas is going to be proportional to the temperature T on the Kelvin scale according to this relation. And when the temperature changes 1 unit on the Kelvin scale, it is equivalent to a change in 1 degree Celsius. They are in 1-to-1 correspondence. So this also I hope you can understand. For example, if we have a temperature of 0 degrees Celsius, we increase the temperature by 1 degree Celsius. So the change is going to be 1 degree Celsius. So 0 degree Celsius is going to correspond on the Kelvin scale to 273 Kelvin and 1 degree Celsius would be 274 Kelvin. So 274 minus 273 is going to be 1 Kelvin. So 1 Kelvin as a change of temperature is going to be equivalent to 1 degree Celsius change of temperature. They are on 1-to-1 correspondence. Note that 0 Kelvin is minus 273 degrees Celsius. So this we have done in detail, that 0 Kelvin is the 0 of the Kelvin scale, the absolute temperature scale, and this is related to degrees Celsius as minus 273 degrees Celsius being equal to 0 Kelvin. So use the following graph of V versus T to answer the next three questions. So the first question is, as the temperature of the gas increases from 250 to 350 Kelvin, does the volume of the gas increase? So from the Charles law, you already know that if the temperature is going to increase, the volume is going to increase. But can we see that on the graph? Let us see that. So 250 Kelvin is here. Just go up and cut on the y-axis where it is cutting. It is approximately 300 ml. And when we see 350 ml and we see the y-axis corresponding to this point, then it is going to be approximately 400 ml. So from 300 to 400 ml, the volume has increased on the increase of temperature from 250 to 350 Kelvin. So this is what we can say, that the temperature of the gas is going to increase, the volume is also going to increase. And then what is the volume of the gas sample at 300 Kelvin? So you can just check that also. So 300 Kelvin is going to approximately in the middle of this here. So this would be somewhere at 350 ml. And what is the temperature of the gas when it occupies a volume of 250 ml? So you can just correspondingly go and check that at 250 ml. So this would be somewhere at around 225 Kelvin. So this was essentially just an understanding of the Charles law, a recap of the Charles law, where the volume of a gas is going to be directly proportional to the temperature on the absolute temperature scale if the gas has on a constant pressure and it is for a fixed amount of gas. The next question is that a certain sample of gas has a volume of 0.2 liter measured at 1 atmospheric pressure and 0 degrees Celsius. At the same pressure but 273 degrees Celsius, its volume will be. So first of all, we should know and ascertain that this is a question related to the Charles law. So we have a certain sample of gas. This means that the mass or the number of moles of the gas, this has been fixed. The second thing, let us find out what is fixed. Yes, it is at the same pressure. So the pressure is fixed. So the mass of the gas and the pressure, they are fixed. The volume and the temperature, they are varying. So this means this is a question of Charles law. So we will be applying the law. Let us see the choices first of all for the question. The choices for the volume are, so we have initial volume, we have the initial temperature, we have the final temperature. We have to find out the final volume, that will be 0.4 liter, 0.8 liter, 27.8 liter or 55.6 liter. So what are we going to do? We are going to apply the Charles law, V1 by T1 equal to V2 by T2. So putting the values in the equation, what you will be getting is that V1 is 0.2. Now the temperature, you please have to remember that you have to convert it into the Kelvin scale, otherwise it will be wrong. So 0 degrees Celsius is going to be 0 plus 273. So we will be having this as 273. Then it is going to be V2, which we have to find, and the temperature is 273 degrees Celsius. So add 273 to this as well, and the volume that you will be getting is going to be 0.4 liter. Another thing which you can recall over here is, while we were doing the last lecture discussion, I told you when the temperature is going to be raised from 0 degrees Celsius to 273 degrees Celsius, the volume of the gas, that is going to double. Right? I hope you remember that. I told you as one of the questions while we were discussing the graph related to the Charles law. So if you remember that, well, you do not have to do all the calculations also. You will be simply able to double the volume. So zero point 0.2 would become 0.4 because the temperature has risen from 0 degrees Celsius to 273 degrees Celsius. So the next problem is that in an air-conditioned room at 19 degrees Celsius, a spherical balloon had the diameter of 50 centimeter. When taken outside on a hot summer day, the balloon expanded to 51.0 centimeter in diameter. What was the temperature outside in degrees Celsius? Assume the ball to be a perfect sphere and the pressure as well as the mass of the gas, they remain the same. So what are we going to do? Well, we have first of all the pressure and the mass of the gas that are going to be the same. So this means that it is going to be a question of the Charles law. Right? So you are given an initial temperature, you have to find out the final temperature. And now what is not given to you is the volume, but given to you is the diameter of the balloon, and it is considered to be a sphere. So you will have to find the volume of the sphere, and volume is going to be 4 by 3 pi r cube. So we will be putting the Charles law as V1 by T1 equal to V2 by T2. From this you will get T2 to be equal to V2 into T1 divided by T1. And then we are going to put things over here. So for the temperature T2, what we will be having, the volume V2 is going to be 51 centimeter diameter cube. So the radius is going to be half of this. Okay. So we will be putting the formula of the volume to be 4 by 3 pi R2 cube into T1 over 4 by 3 pi R1 cube. Fine. So 4 by 3 pi, 4 by 3 pi is going to cancel out. What we will be getting, T2 equal to R2 cube into T1 over R1 cube. So just quickly put down the values. What you will be getting, the answer is going to be 310.3 Kelvin, or when you are going to convert it into degrees Celsius, it is going to be 36.9 degrees Celsius. Now the next question is going to be a graph question, and I hope you all understand that the graph related to the laws, they are going to be very important. We have discussed quite a few graphs while we were discussing the Boyle's law. The last lecture, while we were having a discussion on the Charles law, we saw one of the graph related to the Charles law, which was the most important one for our understanding purpose. So now let us try and attempt this question among the following curves which is not according to the Charles law. So you have four choices in front of you. So the first choice, if you look over here, this is a graph between V and T, and you already know that for the Charles law, the volume is going to be directly proportional to temperature. With an increase in temperature, the volume is going to increase and it is going to be a straight line graph, right? So this question, this choice is going to be correct. Next we have is a graph for log V versus log T. So let us look at the solution to this. So that would be easy to understand. So according to the Charles law, what you have is that the pressure and mass, they are going to be constant. V by T equal to K, that is going to be a constant. So just taking the log on both sides, what you will be getting is log V equal to log K plus log T, and this is going to be an equation of straight line. And this is the equation of straight line according to which log V is on the y-axis, log T is on the x-axis, and log K is going to be the constant. So if it is a constant, it is going to cut the y-axis at some point over here, and that point is going to be the value of log K. Now when we write this as log T, this is going to be mx. Okay, so mx, x is log T, that means m is going to be 1. We have been discussing all these in the Boyle's law questions also, so I hope I do not have to write all these things again. So that means m is going to be 1, and m is 1, that means the value of tan theta is 1. So tan theta is 1 for theta to be 45 degree. So this choice is also going to be correct. Right. So next we move on to this one. So this is Vt by T square. So just simply divide this by T, this by T. What are you going to get? It is going to be again essentially the graph for V versus T. So this is also going to be the same graph as this graph. Now when we come to the graph of V by T versus V. So what we know is that V by T, according to the Charles law, it is going to be constant. Right? If we are going to increase the value of volume, the V by T is going to still remain constant because proportionally the temperature will also increase, so that V by T, this remains the same. Fine, I hope this is clear. So rather than this being this way, it would have been a straight line or parallel to the horizontal axis. So it would have been a graph like this rather than being a graph like this. Okay, so what we have along according to this question is that the G choice is going to be wrong. The next question we have is that which is the correct graph for the Charles law when the graph is plotted for a fixed amount of gas at constant pressure such that V by T, this is equal to 1. So we have again the Charles law. So according to the Charles law, you know that V by T is going to be constant, and here the value is also given to you that V by T is equal to 1. So let us see the first question that we have. So this question is going to be that on the y-axis we have V by T, on the x-axis we have V. So by the straight line equation, y is equal to mx plus c. So I have written this down over here in case you have any doubts. So m is going to be the slope of the line equal to tan theta, and here the value of theta is given to you 45 degree. So m, which is going to be equal to tan 45, is going to be 1. So just putting all these things into the equation, we will be getting the equation is V by T is going to be Y. So we have put this as this, right? So X is V and M is 1. So we have V, and the C is the constant. So V by T equal to V plus C equal to 1, or we can write this as that 1 V by T, we know that this is 1, this is given to us to be 1, right? So we can write this as 1 equal to V plus C, or C equal to V minus 1. So what this means is that if we are going to change the value of the volume of the gas, this value of C is going to change. But what we have in the equation of the straight line, that C is constant. So this means that this option is not going to be valid. right? So now let us move on to the next part. So option 2, what we have is that on the y-axis we have v square by t, and on the x-axis we have v, and the value of theta given to us is 45 degrees. So we will again put its all values into the straight line equation, which is going to be v square by t equal to v plus c now. Now what we will be doing is that we will be dividing the whole equation throughout by t. And what we will be getting is v square by t square equal to v by t plus c by d. We have divided it throughout by t. So v square by t square, we already know the value of v by t is equal to 1. So 1 square is going to remain again 1. So what we will be getting is 1 plus c by t. Okay, so if you take this now 1 to this side, what will be 1 minus 1? So this will be 0. So 0 is equal to c by t, or you can see that c is going to be a constant and the value of c is going to be 0, which means that this is going to cut the y-axis on the origin. So that it is doing, the value of theta is 45 degree, and this is what we are getting. So this is going to be correct, right? So we have chosen the correct choice over here, but because you people are also preparing for JEE advanced questions also, at least the engineering side students plus even the medical students, you have to understand all these graphs well. So let us discuss now the third graph, where it is going to be a relationship between volume and temperature at a value of theta to be 30 degree. So here when going to put the value of tan theta to be 30 degree, what you get as the value is 1 by root 3. So just put all these things into the equation. What you will be getting is v by t. I have now again divided throughout by t. So v by t is equal to 1 by root 3 plus c by t, right? So v by t is going to be again equal to 1. So what you will be getting is c equal to t into 1 minus root 3. So again, the constant C is going to vary according to this equation with temperature. So again, this is going to be not possible. So this graph is also incorrect. The next we have is the graph for log V versus log T, and the value of theta given to us is 135 degree. So, well, if you take the log B, theta is equal to 135 degree, means that tan theta is going to be minus 1. Okay, so we will be putting again into the equation log B equal to minus log T plus C, or you can say this taking to this side, we will be getting log BT equal to C, or you can say BT is going to be equal to log C, or V equal to log C by T. So again, what you can see is that volume, this is going to vary inversely with temperature. But according to the Charles law, what do you have? That volume is going to vary directly with temperature. So this is also going to be incorrect. Okay. And on the other way, what we have seen for this log V versus log T graph in the last question as well, what we found out was that log v by t is constant, so you can write this as log v minus log t equal to c, and log v equal to log t plus c. So here again you can see the value of m is going to come as 1. Right, the C is positive, the value of M is 1, so the slope should not be decreasing. This would have been an increasing slope of the line. So this graph is going to be incorrect. Okay, so the correct choice is going to be this choice. This is going to be correct. Okay, I hope all the graphs, they are very clear to you. The questions, the other part, the numerical, they are very simple questions. They're not very difficult. What you have to understand over here one by one is the graphs related to these laws very well. So that would be all for this lecture, and in the next lecture we would be starting with the discussion on the third law, that is going to be the Gay-Lussac's law. So if you've liked the lecture, please do click on the like link. If you have not subscribed to the channel till now, please do that, and also do click on the bell icon so that you get a notification the moment we put up the new lecture for you. We are trying our level best to give you the best possible education. So I hope you are liking. Please do share your feedbacks. You can share your feedbacks. You have any doubts, you can post them as well into the comment section. You can email them to us at email IDs h2ochemistry@gmail.com, and also at the same time you can join us on the Facebook page of the channel. The Facebook page of the channel is also having the same name, H2O Chemistry. There we are constantly posting questions, so they can also benefit you a lot. So having a nice day, I hope. God bless you. Enjoy your studies.